Okay, on number 9, I think it'd be easiest to cancel the z's. So I'm going to use these first two lines, and I'll write the first line exactly like it's written. And the second line, I'm going to multiply times 3. So it becomes 3x minus 12y plus 3z equals 18. And when I add the two lines together, I get 5x minus 11y equals 19. And then I'm going to use the last two lines, and I can use them exactly like they are written. And when I add them together, the z's are going to cancel. And I get 5x minus 11y, 11y, and the z's cancel equals 19. These two equations are exactly the same, which means they would be parallel, means they would not parallel, they'd be the exact same line, which we looked at yesterday, means there's going to be infinite solutions. All right, number 12 is a little different because the top equation has a P and an R, the second equation has a Q and an R, and the third equation has a P and a Q. So I've got to decide what variable it is that I want to eliminate, and then I can do that. So, for example, this one has Q minus 7R equals 4. What if I just kept that one, and then I figured out a way to use the top equation and the bottom equation to get rid of P. So if I wanted to use the top equation and the bottom equation to get rid of P, because then I would just have Q's and R's, which is what this one has, then I'd be in good shape. So to use the top equation and the bottom equation to get rid of P, I'm going to write the top equation exactly like it is, 3P plus 2R equals 11. And I'm just going to leave a little spot there where Q was. And then for this bottom line, I'm going to multiply it times a negative 3 so that it will cancel with the 3p. So it becomes negative 3p, and then it'd be plus 18q, and I'm going to squeeze it in this little spot here. And then I'm going to skip, and then it's going to be a negative 3 over here because everything, this whole line times a negative 3. That's hard to read. All right, add these two lines together. The p's cancel. You get 18q plus 2r equals 11 plus negative 3 is 8. So line that up over here. This is a 1q. I know it's hard to read. It kind of looks like a 9, but it's q minus 7r equals 4. And then I've got 18q plus 2r equals 8. All right, I'm going to take a poll for my 6th period here, whether they want to eliminate the q's or the r's. It was unanimous. They decided Q. So here I have 1 and here I have 18. So I would need to multiply this top line by a negative 18 if I want to cancel the Q's. So the top line becomes negative 18Q. 18 times 7. Hang on, I'm going to pause and let them do that for me. Plus 126R. Thank you, Madison. Equals negative 18 times 4 is negative 72. And the bottom line I'm going to write down just like it was. Y'all get ready to do some math for me here in just a second. All right, the Q's cancel. Add these two together. I get 128R equals negative 72 plus 8 would be negative 64. Divide by 128. I get R equals negative 1/2. All right, so R is negative 1/2. So now I'm going to go back to a problem that had Q's and R's. And now that I know what R is, I'm going to see if I can find Q. I'm going to use this one right here. 18Q plus 2 times negative 1/2 equals 8. So that's 18Q. 2 times negative 1/2 will be minus 1 equals 8. Add 1, you get 18Q equals 9. Divide by 18, you get Q equals positive 1/2. So now I know what R is, it's negative 1/2, and I know what Q is, it's positive 1/2. And let's see, if I know what R is, I can find P. So, or actually here, this one, P and Q, and then I don't have to do any dividing. Up here I'd have to do some dividing. So P minus 6 times Q, 6 times 1/2, equals 1. So that's P minus 6 times 1/2 will be 3 equals 1. Add 3, I get P is equal to 4. So my answer, and I want to write it as a coordinate triple, you write it in alphabetical order, is going to be P is 4, Q is 1/2, and R is -1/2. And that's my answer for number 12. Okay, number 15 is probably one of the toughest problems that you're going to see. So what I've got is a 4 by 4. So what I have to do is I have to get it down to having 3 by 3, and then I'm going to get it down to a 2 by 2. So looking at this, it looks like it kind of be easy to get rid of some W's. So I'm going to use the first and the third line to get rid of a W, and I'm going to try to do this without having to write it again. If I just add the first and the third line together, I would get 2x, and then the y's cancel, and the z's cancel, equals -4. Actually, that just made it pretty easy. 2x equals -4 when I just add the top line and I add the third line together. W's cancel, I get 2x. The y's cancel, the z's cancel, I get -4. So my x value for this problem is going to be -2. I wonder if we can find any others that are quite that easy to find. Let's see. That helps me. If x is -2, then now I'm down to having just 3 problems. All right, now let's add together the first and the last line. And when I do that, the w's cancel. I get 4x, which I know what x is. It's -2. And plus 2y. And the z's cancel, equals 0. So 4 times -2, that's -8, plus 2y is equal to 0. Add 8, you get 2y equals 8, so y is equal to 4. So now I know what x is, and I know what y is. All right, now let's add the second line and the fourth line together and see if we can figure out another variable. Second line and the fourth line, just like they're written. W and -w would cancel. And then I'd add 2x and 3x, so that's 5x, but I know what x is. It's -2. So 5 times -2, 2y plus y would make 3y, but I know what y is. It's 4, so 3 times 4. And then 4z minus z would be 3z. And 1 plus -2 is -1. So I get -10 plus 12 plus 3z equals -1. Subtract 2, 3z equals -3, so z equals -1. So now I know what z is, what x is, and what y is. So I'm going to just plug into this very top equation. I'm looking for w, so it would be w plus x, which is -2, and y, which is 4, and z, which is -1, equals 2. That doesn't look like a -1, but it is, trust me. So w, -3, that would be w plus 1 equals 2. Because if I combine all these together, I get 1. So subtract 1 and you get w is equal to 1. So my answer in alphabetical order is 1, -2, 4, -1. Wasn't as bad as it looked.